Aloha. In this video, we're going to be talking about the HashMap container. So we're going to go ahead and share the screen. So the HashMap. So some people may be familiar with the dictionary concept. The dictionary works in key value pairs. This is similar, but it's a little bit more elegant on the back end. It's a lot more efficient than using a dictionary. So dictionaries are pretty much obsolete. In Java, you're supposed to use the hash map instead. So to explain it briefly, the hash map is used to take key value pairs. So if, just like the old dictionary style, you would have a key and that would map to a value. So let's say you had states and their populations. You'd have HI and then you'd have a number that's associated with that. It could be anything though. It could be scores. If you were reading in a string and you wanted to count the number of L's, you could have, you could do a hash map of that. So you could loop through it, and for each letter you find, you could create a key with that letter and then the count on the other side. So that's what there's a lot of different uses for the hash map. But the hash map, it's derived from the map. It's divided. It's actually a collection, and it implements the map interface. And if you want to use this, you'll go ahead and use the statement import java.util.hashmap semicolon, and that's going to enable you to use the hash map. So the hash map, it's an abstract data type. It's implemented as a generic class. That means we're going to be able to use our own types with it. So as you see in the declaration here, you can set it up using HashMap. The KV here stands for the types that are going to be used for the key and the value. So you put in like string and integer, and HashMap new HashMap string integer over here. And then let's see, you have some two of the most common functions or methods that are associated with this are put and get, and that's going to allow you to put things into your map and get things out of it. So we're going to take a quick look right here in the participation activity. Go ahead and start that. We're going to instantiate it right here with this the HashMap call here. Then we're adding items in. You can see it go ahead and populating that. So it's putting in CA with the value here, AZ with that value, and MA with the 6692824. So it puts all those things into our hash map. And now we can access those values after we stored them. And again, I've mentioned before, you can use this for configuration files. If you have like configuration settings, you can do these in maps as well, these hash maps. So so over here, HashMaps put method replaces the value associated with the key. So one thing to know about the put method is that when you use put and you don't have a key already of that value, or if you don't have a key, let's say you're putting in John as your key. If you go to insert that and you don't have a key with the name John, it'll insert a new key in there. So your hash map is going to be increasing in size. If you do, however, have one named John, what's going to happen is the value in the value part of it is going to get overwritten with whatever you're putting into it. And we'll take a look at that right here. So we start our animation here. Using put with an existing key replaces the value associated with that key. So you see that it puts in 3 values right here. It goes and tells you what the population of Arizona is. Then it's doing a put on Arizona. And you see that it overwrites the value that was there previously. So then it updates, it says, and the population in 2014 is, and it prints out that new value. So just note that put will put something in if it's new, and it'll update if it's not new. So now we've got basic hash map operations, put and get. We're going to have questions on that. So it shows you here an example of one being set up to associate strings to integers, and it gives you names and numbers. So it's going to start testing you on how to use that. So write a statement to add a mapping for a player named Kiro with a score of 1. So what I like to do is I like to just go up here and grab something that already exists, do a copy of it. That way you got the exact syntax. Then you can just go over here and change it to the value that it's asking for. And you, oops, hold on, because I wasn't paying attention there. Write a statement to add a mapping for it. So, oh yeah, so keying one. So what did I do wrong here? So player scores dot put keying. Oh, Kira. Okay, yeah. I'm thinking in Japanese, keying being giraffe. So we're going to check that, and of course that works. So then you can go ahead and do other things like write a statement to assign Hutchings score to a variable named high score. So for this, one thing you want to keep in mind is you don't need to initiate it. Just pretend it's already initiated. I didn't really like that, but yeah, you just do the assignment here. You don't have to worry about actually creating it. They should have created it up here for you, but let's just go ahead, copy and paste high score here, then equals, then to assign Hutchings new score. So I'm just going to grab this because I'm lazy in general, and I like to put that in there, and then I'll just close off this. Don't forget your semicolon. Then we'll come back over here, and we know it's not a put, it's a get. So we're going to get the value there, and then we're going to hit check, and it's correct. So go ahead and work through the other ones here using the same ideas. It's just testing you to see if you remember different aspects of the methods that we have there. So we also have a way of determining if a key exists. So if you're going to do a get, if you don't have a value for that key, it's going to return a null. So if you're doing operations on getting things and you don't want to check, well, basically you have to be careful because if it returns a null and you're using that directly in your calculation or whatever it is you're doing, you're going to get a problem. So one thing that you can do beforehand, you can do a containsKey call, and containsKey using using your hash map, it's going to tell you whether or not it actually exists first. So you can say if, let's say for this example, state population.containsKey of New York, then if it exists, then you can call and code after that. So over here, they have some example of that. So use containsKey to check if the hash map contains the specified key. I think they mean user specified key. The program uses a hash map to associate a race distance in kilometers with a runner's race time. If a distance does not exist, the program prints null. Modify the program to use containsKey method to check if the runner has run a race of the specified distance and display a message of no race of the specified distances. So if we look in here, we see that they set up our hash map here. They're scanning in that input to, for the, hey, do you have that distance? So they go ahead and they start populating the hash map with 5 to 23.14, 15 to 78.5, 25 to 120.75. Okay, that's fine. Then they're putting out the, hey, enter race distance in kilometers. You're going to scan in the next integer, which is, I guess they're not doing a marathon because that would be 26.4. So it's an integer. So they're going to look over this. They're going over while user distance in kilometers is not 0. So essentially you use 0 to exit out. While it's not 0, you're going to say best time for whatever is whatever, and then you're going to print it out after you get it. But of course, this could yield nothing, so it's going to look weird. It'll say best time for whatever distance is null minutes. So that's not going to look very pretty. Then it hits an enter and goes to the next line and says, hey, enter a race distance in miles. So they give us some values here. These are our inputs. So let's go ahead and see what happens when that goes through. So we know looking at this, we've got 5, 15, and 25. So 5, 15. So 10 the last one should say null distance. Yeah, so over here it says null minute. So we want to eliminate this essentially. So we're going to look up here. They've already defined the hash map for us as race time. So let's go ahead and copy that. So when we look in here, we get the next integer, and then we go in here and we say, okay, so let's put in an if statement around here. So we're going to print it if it exists. If not, we're just going to move on from it. So, and I don't think they're going to check we're just going to have to figure it out by looking at our results, whether we got what we wanted. So we're going to say if race times dot is it contains key of, and we're going to use the user distance kilometers. If race times dot contains key of that, yes. And then if it returns true, this will evaluate to true and it'll run the next part. So we do all of this stuff right here. Else, we're going to do this, and we're going to print out. Well, I'm just going to cheat and grab a line here because I'm lazy. I mean efficient. And then we're going to just say no race of this type exists. Don't forget that period there because they are pedantic. So we're going to do this, else. So is our logic right? So if it's not 0, we're going to come in here. We're going to say if it contains the key, we're going to print it out. Else, we're going to say no race specified. Then we're going to ask again for the next. So let's see what happens. Please, no whammies, no whammies. Yes, it ran. So we have proper. And then for this one, we say no race of the, yeah, so that looks pretty good. So this is what they wanted. So go ahead, code this on your own, try it out. Just get some muscle memory in your fingers to make sure that you can use the contains key properly and everything. But yeah, go ahead and type that out, try it. Then given the code below, determine the result of each expression. So we're setting up a hash map of integer and double called race times, just like we did above. So we have 5, 15, 25. Okay, so this is easy enough. So race times contains key of 10. Does it? You can look in here and say easily, no, it does not. So no, and then you can do these on your own. I'll let you do that. Ooh, do keep in mind they say contains key, and then get. So yeah, be careful of that, because that's going to test your knowledge of what's going to happen. And we talked about this up above. We talked about what happens when you do a get and you don't have an actual key there. It's going to return a certain value. I mentioned it, so that's testing that. So common hash map methods. We've got put, which we've talked about. It's going to put in the key with the specified value. If it exists, it just replaces that value. Otherwise, it inserts it, and the size of your hash map is going to grow. putIfAbsent. Now, this is nice because what's going to happen is it's going to allow you to add it only if it's not already existing. So let's say you have a situation where you want to add something only if it doesn't exist. So you don't want to overwrite something. You just want to add it if it's not there. And this allows you to do that. Get, we talked about that. It returns something if it has a key. It returns the value. If not, it's going to return null. Oops, I just answered your question up above. Contains key. You give it key as the argument there, and it's going to say whether or not it exists, true or false. It's a Boolean result. Contains value. This is nice because now you can check to see if a value exists. So it's going to return true if at least one of the keys that you have is associated with the value. And that's kind of nice because if you had to look that up, if you had to write code to do that yourself, you're going to have to loop through the entire list of keys and do a check on every one of them. But this method right here efficiently returns that for you. Just says, hey, because you want to say, do I have for the race time thing up there, do I have any that I finished in like 40 minutes even? And you'd have to search one by one. But this right here with the contains value will pull it right up. Remove is going to remove the key. So if you have like a race of 5 kilometers and you want to erase that one because let's say it's a new year and you're only counting this year's race numbers, then you can do that. You can do the remove of the key and it'll remove it from the hash map. And once again, your size of the hash map is going to change. Clear zaps them all. Clear just empties everything. KeySet. KeySet is returning a set containing all keys within the map. Set is a specific word here. Set refers to a unique set of items. So you can't have any two in there. So if I had a key of John, I can't have another key of John in there because they wouldn't hash the same value. So that's why it's using a capital S on set. Set has a specific meaning. We'll talk about set collections later. Not in this lesson, but in another in another lesson. And then values. So keySet, again, it's going to return a list of all the keys that you have in there. And then you can also return all the values that you have by calling on the values method here. So that's going to return a collection containing all the values within the map. For participation, again, we're doing a hash map here of string to integer, people to numbers. Not sure exactly what that is for, but anyway, you can go in here and say put if absent, like Mary 17. You look up here, is there a Mary? Yes, there is. It's now 17, and it's asking which of the following operations modify it. Does that modify it? Yes, it does. Wait, hold on. No, hold on. Put if absent Mary. Oh yeah, Mary is there, so it's not going to put it in. So that doesn't do it. So put if absent Frederick. Frederick is not in there, so it's going to So putting in Frederick is definitely going to add to it. So so just go through here like this and see, does this modify it? And you'll see for all the different values. This one right here, I'll tell you, it's testing you on something it hasn't mentioned, and that's whether or not it's case sensitive. The keys are case sensitive. I'll give you a hint. They are case sensitive, and you'll learn that by clicking on the wrong one. So then we come down here. We've got our hash map. So with this code, they want you to start putting in the program's output. So go through here. I won't do this right now, but why don't you go through, look, they're setting up a hash map here, string to string. It looks like they're doing airport codes to places, and then they're printing out GRE colon, GRX colon space. Then they're doing a get to figure out which one it is, and then they're printing out the place beyond it. Then after that's done, it's going to print out IWJ, do that, and that's all. So that's simple enough. So if you were to start it, you'd come up here and you'd see these come out. So you'd have to print out the one for LNZ and ALB. So I'll do one of these just to have some embarrassment. So if we're going to do this one, I'm just going to copy it because remember it cares about every space and carriage return in there. So LNZ is going to return this value right here. If they're actually make sure they're doing a get. Yeah, they're doing a get of it. So we're doing a get right here. So then we're going to put that in there and make sure that's still just the one space. Yes, it is. So then we go down here, put in a space, and grab Albania, or Albany. Oops. Yeah, Albania, sorry. We had the one space. And we're going to put Albany, USA. So I'm guessing that's New York. And then do we do put print, then print. Yeah, so we just do that. So there is no print. Oh, it is a print line. So we have to put in our enter after there. So theoretically, that is what it should look like. And it's giving me an X, of course, because I've done something wrong here. Put associates. Oh, because I'm not paying attention. I wasn't paying attention. So so after this is why you really need to read through it. I'm just trying to skim it and do it. We have a put here, so we're doing a put over Albany before we do it. So we're putting Ambler USA over it. So mine should have said Ambler USA. So I don't get to revise that, I don't think. I don't get to revise it, but now they're going to retest me. So now, shame on me. So we go up here, ALB, print out our ALB again. And we get that. And we, so print out ALB, we're going to print out what it gets to. So you grab that, put that in there. Careful about making sure we have our enter there. Then after we do that, it puts MLN to this thing right here. So we can trick ourselves again. So we take our MLN right there. We put in Monday, Ethiopia because it's changed. And make sure we're doing a get of that. Then we hit enter, and hopefully it Yeah. So this is what it does. Just pay attention to what they're saying there. I was, yeah, just kind of skimming it and thinking they're just asking for the two in a row. So anyway, go ahead and do that. Then hash map with enhanced loop. So this was neat. Oh, okay, yeah. This is a good little programming assignment. So declare variable score and grade as a hash map with character key type and double value type representing a grade and the minimum score of the grade. Read integer data count from input, then read data count key value pairs from input and insert each into score and grade. If the score already exists, do not replace the key's value with the new value. So you can already tell that you have the putIfAbsent method. So example, the input is 3, so that means you're going to be taking in 3 pair values. So you have 3 of them inserted there. Then one possible output is key C value 70.5, key A value 89.5. So note the order of the keys is not guaranteed in the hash map. That's something important to keep in mind. So anyway, go ahead and modify your code. You're going to put your variable declarations right here. Then your code's going to go down below that. So yeah, so go ahead and code this up. There's 4 different parts to this one. And what it just said here is kind of important. The order of the keys is not guaranteed in the hash map. So there's a mention here that you've got hash map and tree map. And when do you use each one? They're both abstract data types that are implemented using the map interface. But they both implement map, but you should choose which one is appropriate depending on what your task is. So hash maps, they're typically faster, but you can't rely on the order of the keys. So this is something people that use dictionaries know this. And if you're using Python, I think Python before a certain version, they didn't guarantee the key order. So in other words, if you insert one key before the other, usually when you would display the key order up until a certain version, it was random or pseudo-random, the order in which they come in. But I think in later versions of it, they've kept the order of the keys. I could be wrong, but I do know that it switched at one point, and I think it's currently you are guaranteed key order. But in this, hash maps do not maintain the key order. So if you needed that feature where you would retain that, that would be through the tree map. Just know that it's going to be a little bit slower access with the tree map, but otherwise, yeah, they're very similar, but they do have those trade-offs in performance. So anyway, that's hash maps. If you have any questions, need any help trying to understand this, let me know. I talk as if people understand dictionaries, but in case you don't, hopefully this explanation was good enough. If not, reach out to me. Let me know. I'm always happy to help. Just send me an email and I can set up a Zoom session with you. Otherwise, have a great day and I'll see you in the next video. Aloha.